Today we're going to talk about some theorems that involve parallel lines. So if two lines are parallel, then all points on one line are going to be equidistant from all points on the other line. So what I have is line M. If line M is parallel to line L, then I can say that from A to C, dropping a perpendicular down, that segment is going to be equal to BD. Now let's look at why that is. A is parallel to B because they're pieces of larger lines that are parallel. Now angle ACD is a right angle and BDC is a right angle. Thus, because I have same side interior are supplementary, I know AC is congruent to BD. Thus, ABDC is a parallelogram, and opposite sides of a parallelogram are going to be congruent. Another theorem that we're going to talk about in this section, which we're going to be dealing with a lot of algebra problems, is if three parallel lines are cut off congruent segments on one transversal. So let's talk about what that means. I have WA. So if WA is parallel to XB, which is also parallel to YC, and there's two pieces to that if part, and I cut off congruent segments on one transversal. Let's say WY is our transversal. We could have made the other one our transversal, but we cut off congruent segments. So I know WX is congruent to XY. So WX is congruent to XY. Then no matter how many other transversals I draw, I can say that then AB is congruent to BC. We're going to be using this in a lot of different algebra problems. Our next example is an algebra problem where you need both of those pieces of the given. We're given that AR is parallel to SB, which is parallel to CT. So I have one piece, and then they also need to tell you that RS is congruent to ST. By that last theorem, BC then is equal to AB. So set up an equation. AB is equal to 13, BC is equal to 7x minus 1. So 13 equals 7x minus 1. I add 1 over. We solve for x to get x equal to 2. So that's really how we're going to be utilizing that other theorem in terms of our geometry class. The next one. If a line that contains the midpoint of one side of a triangle, so let's name our triangle, let's name it X, Y, and Z. A line that contains the midpoint. So let's say that if A is the midpoint of X, Y, so that's the first piece, and is parallel to the other side, and AB is parallel to YZ, then it passes through the midpoint of the other side. Then, finish my then, B is the midpoint of XZ. So I have XA congruent to AY, and AB is parallel to YZ. Thus, then by this theorem, this BZ is congruent to XB. Really, we use this theorem for our triangle midsegment theorem. Our triangle midsegment theorem. This is a really, really important theorem. This says that the segment that joins the midpoints of two sides of a triangle. So let's name our triangle A, B, C. Let's call that X. Let's call that point Y. Segment that conjoins the midpoints of two sides. So X is the midpoint of AB, and Y is the midpoint of AC. There's two things that come out of this theorem. The two things that come out of that. So I have that congruent to that, that congruent to that. It is parallel to the third side. So if I have the midpoints, then X, Y is going to be parallel to BC and is half the length of the third side. So X, Y is, remember is equals, half BC. Another way to look at that is twice XY is going to be equal to the length of BC. So using this in algebra, we're going to be using this a lot in algebra, and this is one of our system of equations. Segment joins the midpoints of two sides. So I know this is congruent to this, that side's congruent to that side. Solve for x and y. Well, I know 3x minus 2y is equal to 8. At the same time, I know this side 7 is half the length of 5x minus 3y. So 5x minus 3y equals twice 7, which is 14. System of equations. It looks like elimination is going to be our best bet. I'm going to multiply that whole equation by 3 to get 9x minus 6y equal to 24. I need my coefficients to be the same value but opposite sign, so I'm going to multiply by a -2. Make sure you're multiplying all the terms by -2. -10 plus 6y equals a -28. Now combine your two equations. We get a -x. The 6y and the -6y cancel, equals -4. Therefore, x equals 4. Now solve for y. I bet you the first equation is going to be easiest. 3 times 4 is 12, minus 2y equals 8. -2y equals -4. That's a negative sign in there. I have a negative sign in there. Divide by -2. Y is going to be equal to 2. So we did a couple theorems. Make sure you remember the mid-segment theorem. There are your lesson questions. Remember, they are due by 8 a.m. on the due date.